Welcome! Today, we're excited to explore the latest release of CET.SteelConnDesign, version 1.6, with a focus on the beam-to-beam web connection. We'll also discuss how to seamlessly integrate our software with Tekla. Before we dive in, ensure you've successfully downloaded and installed our software. Now, let's begin. Firstly, in Tekla, we've already created 3 members. A W18 by 60 member named B1. A W14 by 99 member named B2. And another W18 by 60 member named B3. Remember, these unique beam names are crucial as our software utilizes them for creating connections. Keep in mind that the top elevation of all 3 beams should match. This demonstration aims to establish connections from beams B2 and B3 to beam B1. Our system should be initiated after Tekla. Once loaded, you'll notice the version number is 1.6. A new button labeled Open Manual provides access to a PDF user manual for reference. Users have the option to review the user manual at any point during the design process. Clicking the Scan Model button will bring all members' information from Tekla and display the Tekla model name in Model Name field. Within the Connection Setup options, a new addition, called Beam-to-Beam Web, is ready for exploration. After scanning the Tekla model, 3 beams are visible in both the beams list and the other beams list. Let's select B2 from the beams list and B1 from the other beams list to create a beam-to-beam web connection named B2_B1. Similarly, we'll create a connection from beam B3 to beam B1 called B3_B1. Now there are 2 connections in the list. Switching to the Connection Design tab, you'll find B2_B1 and B3_B1 in the connection list, together with a visual demonstration of the beam-to-beam web setup, including annotations for top and bottom copes. Once you've designed the B2_B1 connection, you'll notice that the single-plate connection appears in Tekla. It's worth noting that input for axial force or moment is limited in this connection setup. Users can modify the cope dimension. For instance, we can alter the cope length to 5 inch and cope depth to 3 inch. Checking the connection properties in Tekla will show that our system automatically inputs values for the user, resulting in significant time saving. Next, we'll proceed to design the B3_B1 connection. Upon completion, you'll observe that the beam web connection B3_B1 has been successfully established, with beam B3 coped at both the top and bottom. Once again, we can adjust the cope length to 5.5 inches, the depth to 3.5 inches and the radius to 1 inch, if desired. Now let's select the web plate as the design part and change the bolt diameter to 1 inch. Consequently, our system will design the connection based on user inputs and modify the 3D model in Tekla. Of course, you can undo the last changes and revert to the previous design. Additionally, we have updated the summary section to include 2 new checks for the coped beam web. Let's examine the new checks in the detailed report. The detailed report has been enhanced to include assessments for coped beam flexural rupture and flexural local buckling. You can now review the step-by-step calculations presented in a neat LaTeX format. It's important to note that there are differences in the flexural local buckling calculations between the AISC 14th and AISC 15th formulas. That wraps up today's session. We appreciate your presence, and until next time, goodbye.